Security is going to be a constant recurring theme in our networks. We need to protect ourselves from extraneous attackers and also people who may be on the inside of our infrastructure that are afforded some level of trust that may be able to or be driven or motivated to take advantage of that trust. Now, we've talked about some of the basic components and some of the risks. What I want to do right now is I want to move into a conversation about how we can actually protect our devices, a concept referred to as device hardening. How do we implement this? And then we're going to find that we're going to implement it on a case-by-case basis. And there's going to be some pretty hard and fast and simple rules that we're going to want to follow. First is going to be focusing on the concept of unused ports. So let's take the scenario where I have a switch. And let's say I have 5 computers connected to my switch. And I have 1 server connected to my switch. Now in this scenario, I have 6 total connections. However, this switch may have 24 ports on it. So what I'm going to do is to protect myself, the best way possible is to take a look at the unused ports that I have, and what I'm going to do is I'm going to mitigate my security risk by simply disabling those interfaces. So now if a cyber attacker were to come in and take one of these unused ports and try to hook a computer up into it to use it to be able to attack my infrastructure, this port is actually disabled, therefore this process can't take place. A very simple and straightforward approach, but something that a lot of people really don't think of. Disabling interfaces is probably one of the simplest and most straightforward approaches to providing security that we have in our infrastructure. And in order to be able to do that, it's going to be exactly the way we've done it in the past. Go under the individual interface, turn the interface off. I can execute the show running configuration and see which interfaces have shutdown configured on them. I can also look at my show interface brief and be able to see the same thing. So again, turn off interfaces that we're not going to be using in our infrastructure so that we mitigate the risk of someone being able to attack us. Now that leaves the ports that we are using. So on a switch, one of the options is what we've got highlighted right here, port security. Port security is very important to us because this is going to define how we're going to treat ports that we're going to be using in our infrastructure. So here's the situation. One of the situations that we need to look at is how do we secure used ports? Well, one of the things that we want to do is that we want to use port security technologies to prevent users from getting unauthorized access to devices that we have in our infrastructure. One of the perfect components in this scenario is a telephone. IP telephones are actually switches. So one of the things that someone could do is unplug their computer from the back of their telephone, plug in a laptop, and ideally they could possibly get the opportunity to be able to leverage our network. These are things that we want to take care of, and we're going to do that through this concept of port security. Port security applies specifically to the concept of switches. Switches are going to have lots of ports and lots of connectivity, and they're going to normally be accessible from the closet or accessible by reaching over and unplugging a wall jack and plugging in another device, or getting another switch and plugging it in. And what we're going to find here is through the concept of port security, we're going to mitigate that process. Because port security allows me to restrict access based on MAC address. Now, what happens here is that I'm going to be able to set my system up to where I can have dynamic MAC addresses, where I can limit the number of addresses that I may have on a port. So if I turn port security on by default, it's going to allow me 1 MAC address. So it's going to assume that I have an individual host connected to it. Now that may be problematic if I wanted to have a switch or if I ended up having another or a group of devices that are connected. But the main idea here is it's going to give me the capability of having 1 MAC address by default. Now I could even come in here and statically configure MAC addresses that are and are not allowed. Now I also have the capability of using this in combination together, both static and dynamic. And the other concept that I have is something referred to as sticky learning. Sticky learning means I'm going to turn on the process and enable MAC address sticky. And what's going to happen is every address that I learn, it's going to enter those MAC addresses under the interface of the configuration. So under the configuration interface, I'll see all of the MAC addresses that are being learned. Now, if I want to store those, I have to save my configuration. And by saving my configuration, that's going to copy everything that I've already learned to my running config. So if I restart, that's going to be in my non-volatile random access memory, which means it's going to come back up when I bring my device online. Now, if I don't do that, that means I'm going to have to go through this sticky learning process all over again when I bring up my device because I did forget to save. Now, looking at what's happening here, port security is very, very secure out of the box. So for instance, when we start looking at this, all I do is enable it, first of all, by typing the switch port security command. Now, once switch port security is on, what I'm going to end up having to do is I want to specify some of these other criteria that we were talking about. So first of all, I enable port security. After port security is enabled, I have the capability of defining the maximum number of MAC addresses that I can have connected to this particular value or this particular port. And I can even employ that sticky process whereby I can tell the system that I want you to record the MAC address that was connected. Lastly, I can set up what's called my P-secure violation process. It can be shut down. It can be different variables or restrict. The main idea here is that if I say shut down and somebody breaks the rules, that port is going to go down and that port's going to stay down unless I as an administrator go in and re-enable it, or I use a process referred to as error recovery in order to automatically allow the port after a designated interval to try to bring itself up and become operational again. So if I want to learn about the configuration, i.e. what port security parameters are configured, I can use the show port security interface, specify the interface and the interface number, and it's going to tell me everything that I want to know about this particular configuration. So looking at this, we're going to see the output here. It's going to tell me that port security is enabled. It's in a secure up. The violation mode here is shut down, and it's going to give me all of the information associated with what's involved with that interface, to include the last address VLAN that was used or accessed the system. So again, these are all important components, and like I said, we have the capability of verifying this using a number of show commands. The show commands, again, are going to be ideally this idea of show port security. Now, when we go in and we look at this, what we see here is what happens if our port security violation has been tripped. Notice it tells me that my status is secure shut down. Now, that means this port is actually disabled and not able to forward traffic in my infrastructure. That can become problematic for me. And like I said, one of the options that I may have is I want to possibly not penalize myself. So let's say I've got a user, Bob. Bob's always causing problems. Bob keeps playing around with things and he keeps bringing his port down because he's trying to figure the network out, or he's got GNS running on a laptop and all of a sudden it's generating information that I don't want on my network. So I'm going to shut down my port. Now, recognizing that that possibility takes place, like I said, we can execute the show commands where we do the show port security and we look at the specific interface. But one of the other options is also to implement just a regular old-fashioned show interface status. And the show interface status is going to give me information associated with whether or not my connection is connected, not connected, or error disabled. So keeping in mind the fact that this process, P-secure violation, is going to put my port security configuration down. So again, show port security, I can look at the address that did it. I can also look at the show port security configuration of my entire device. Now, when we mentioned disabling unused ports, one of the things that we talked about was the fact that we can turn off the ports that we're not going to be using. So just go in and shut them down. Well, ideally and easily enough, or curiously enough, we can actually do the same thing for services. Services are going to be the processes that are going to be running on our routers that we are initially, routers and switches, that we're going to be listening for communications on. But the point is that if I'm never going to use trivial file transfer protocol, what I'm going to end up happening is I may want to disable this process. So on some Cisco services on Cisco devices may not be needed. Therefore, what we're going to want to do is we're going to want to disable them. Notice the show control plane host open ports is going to tell me what ports I'm listening to, and also whether or not they're TCP or UDP in nature. It even goes so far as to give me the names of the services that we're going to be deploying. 49 for TACACS, 67 DHCPD receive, 22 secure shell, 23 telnet. So as we go in and we're looking at all of these configurations, what we may find ourselves doing is entertaining the possibility of just simply disabling the services. So unused services, we don't want them running. So let's figure out what's going to happen and what's involved in turning them off. What are some of the services? Well, we have a number of services that are usually referred to as small servers. So small servers describe services. They include like the finger command, identification, TCP and UDP small services or small servers in their own right. And what needs to happen is that we need to understand that we want to disable those if we're not using them. We also have the capability and the requirement in some instances to enable CDP. Because remember, if Bob went and bought an IP telephone and he plugs it into a switch, it's going to recognize the fact that it's an IP telephone and possibly be able to bring up the port, especially if I didn't shut down an unused port. So one of the things that I may want to do is disable CDP. I can disable CDP globally, or I can disable CDP on an interface by interface basis. So again, it gives me the capability of being able to protect myself. The other thing is that Cisco highly recommends that we disable HTTP, but what we can do is we can leave secure HTTP running. Now, why would we want to use HTTP? Well, bear in mind, we have things like SDM, the idea of being able to use a graphical tool to do basic or rudimentary configuration on a router or a switch. It's going to require us to be able to host a Flash-enabled web page. That means what we're going to do is we're going to end up needing HTTP to access the system. If we turn off HTTP, we can still access it using HTTPS, secure HTTP, so we can actually get the services and the GUIs without having to have a security risk where anybody can access the system and see things. Now, I mentioned CDP, Cisco Discovery Protocol, and I mentioned turning it off. I said we can do it globally, and we do it globally by executing the no CDP run command. Now, if I want to disable this on an interface by interface basis, the command is to go to the interface in question and do no CDP enable. And if I want to disable my HTTP server, I'm going to type no IP HTTP server, and it's going to disable that service. Now, we're also going to have the HTTP secure capability, but bearing in mind that that's going to extend to the different elements. Now, another thing that we need to concern ourselves here with regard to security is time. Because there's nothing more confusing, more annoying, and more compounding than to try to figure out when someone attacked our infrastructure if we don't have synchronized time. So if someone hit a server in, say, Argentina, and it's got running their own time, and we're running our time here in the United States, and I'm trying to look at all the logs to see when our security was leveraged, what I need to understand here is I need a tool that's going to make certain that my time is synchronized amid all of our devices. And what that's going to be is NTP, Network Time Protocol. NTP works on our network, and it gives us correct time, and it gives us synchronization. It's going to allow our time zones and the tracking events in the network in the correct order as when they happened. It's also going to allow me to do clock synchronization, which is going to be critical for things like syslog data, SNMP information that we're going to be sending out, as well as just the console messages that are going to be appearing on our infrastructure. The other thing is we can use clock synchronization for digital certificates. Or, as we're going to find out when we start talking about our IGPs, we're going to have the capability of using some level of authentication to make certain that third-party devices or rogue speakers, or IGP speaking, OSPF speakers, EIGRP speakers, or OSPF speakers, can't be just added to the network willy-nilly. So again, NTP is going to be extremely important to us because when our keys or our certificates expire, we need to make certain that we're accepting and receiving the keys in the same time frame. So if time is off, I may stop accepting a security key or a certificate while I'm still sending it on another because my time is not synchronized. So that means NTP, or Network Time Protocol, is extremely and exceedingly important in setting up my infrastructure. Now, what's going to end up happening here is that we're going to use NTP to do that entire process. We're going to synchronize time, which means we need to have a device that's going to be authoritative for time. Now, that's typically going to be some type of atomic clock, a cesium clock, a sidereal, or a GPS clock. Now, we can also lie to the system. We can come in and tell the system that you are a NTP master, and what we can do is we can assign a value called a stratum. A stratum is the believability or the accuracy of time. So if I am attached to a Stratum 1 device and I start sending that time or advertising that time to other devices, my stratum is going to increase all the way up to a stratum of 16, which is going to be unbelievable or considered insane. Now that means that time is not going to be relevant, accurate, or trusted. Now, like I said, it can go with the idea of a local master clock. It can be a GPS or an atomic clock of some type. But the main thing that we need to understand here is that NTP is a client-server protocol. Now, when we want to configure NTP, the commands are extremely simple. I can identify the identity of an NTP server. The NTP server can be entered using NTP-server and the IP address of the NTP server. So in this scenario, 201.15 is my NTP server. So it's providing authoritative time. Now also bear in mind that on this branch device, I could be learning my time. So if my time here was a stratum 1, when I advertise it to another device, it'll be learned as a stratum 2, letting me know that I have 2 devices or 2 points of temporal deviation. I know I sound like a Time Lord, don't I? But the idea here is that on our individual devices, I can actually use a client that has time as my time server. So again, this can be an NTP client of this router. This router will be an NTP client of this NTP server. And again, we can also lie to our infrastructure, and we can use the idea of the master command. Now, if I want to verify NTP, I have 2 commands to do it pretty much. I have show NTP status and show NTP associations. Show NTP associations tell me about my neighbors, the devices with which I'm getting my time from. The second scenario here, or the show NTP status, is giving me my actual status, whether or not I've synchronized on the time that I've learned from whatever device I'm using as my server, irregardless of things like stratum. Notice that the stratums here are represented. My neighbor here is a stratum 1, so show NTP association is telling me this device right here is an authoritative time server. However, the time that I learn from it, once it's synchronized, is a stratum 2. So keep in mind, this entire process is that we want to increase the stratum in order to be able to better represent what information is going to be believable and what information isn't. Now, like I said, security and time go together. So more often than not, most of our scenarios are hardening just simply means doing intelligent things. We're going to disable ports that we're not using. We're going to turn off services or servers, small servers that are running on our switches and our routers that we're listening to communications for in the hopes that the connection is going to be formed. Also, in order to be able to synchronize time across all of the devices of our infrastructure allows us to do better forensics in the event that something has happened. Now, this doesn't end our conversation about security, because now what we want to do is we want to start turning to access lists and finding out how access lists are going to be able to allow us to filter traffic. We've already seen some examples in the lab, so let's dive right into that lesson. I'll see you there.